All right, so today we're talking about finding parallelogram area and perimeter using trigonometry and the Pythagorean theorem. There are three problem types that I'm going to show in this video. First type is when we need to use trigonometry to find the height of the parallelogram. So you might have a figure that looks something like this. We can see the two side lengths are 15 feet and 12 feet, and we can see a 60-degree angle in there. So finding perimeter here is easy because we already know all the side lengths. We know that in a parallelogram, opposite sides are congruent, which means that we can fill in these other two missing sides as 15 feet and 12 feet again. And then to find the perimeter, we just need to add up all the sides. So we're doing 12 plus 15 plus 12 plus 15, which gets us a total perimeter of 54 feet. So again, this time, both of the side lengths were given. Finding the perimeter just involved adding up all of the side lengths. That one is easy. When we're finding the area, we are going to have to use trig because the height is always measured perpendicular to the base, and we can see because of that 60-degree angle that our 12-foot side is not perpendicular to the base. So what we need to do here is we need to draw in a perpendicular line for the height. I'm calling it H here. And I've done it over on the corner so that I have a nice right triangle on the left-hand side. Using that right triangle, we can go back to what we were doing a couple weeks ago with trigonometry. We can say that the sine of 60 degrees is h over 12 because sine is opposite over hypotenuse and h is the opposite side, 12 is the hypotenuse. Cross multiplying, we can say that 12 times the sine of 60 degrees is h. Punch that into the calculator. Our height is 10.39 feet. And then the area of a parallelogram is base times height. So we can multiply 15 for the base times 10.39 for the height we just found and say that our area is 155.85 feet squared. So again, we used the slant side that we knew and the angle that we knew to find the height inside the parallelogram, which we then used to find the area. So that's problem type 1. The sides and an angle were given. We needed to find the height. For problem type 2, we're going to need to use trigonometry to find a missing side. So in this example, we are told the height inside the parallelogram. We don't know the slant length along the side. So this time finding the area is easy because area is just base times height. So we can do 10 times 8 and find that our area is 80 feet squared. Again, base times height, we've already got the perpendicular height to the base. That one is nice and straightforward for us. Finding the perimeter is going to involve using trig. And this time we're going to have to do a little bit more work to get to that trig. This won't necessarily happen every time that you have to do a perimeter problem with trig, but I gave us the 120-degree angle here, which is not exactly helpful for setting up a right triangle. So we're going to have to use what we know about parallel lines to find the angle on the other side. We know that parallel lines have same side interior angles supplementary, which means that we can say that other angle on the other side is 180 minus 120. So we know that that angle is 60 degrees. We still don't really have a right triangle here, so we're also going to take our 8-foot line and just scoot it over a bit to make a nice, neat right triangle for ourselves. And then we'll call the slant side that we're trying to find x. So then using trigonometry again, we again have the opposite side and the hypotenuse, so we'll use sine. We'll say that the sine of 60 degrees over 1 equals 8 over x. Cross multiplying, x times the sine of 60 degrees equals 8. Divide both sides, we get x equals 8 over the sine of 60 degrees, and punching that into our calculator, we get that x is 9.24. So then finding the perimeter, we're going to have to add up all four sides. So we've got 9.24 plus 10 plus another 9.24 plus another 10, and our perimeter here is 38.48 feet. So again, this time we had to do a little bit more work with the angle, but we were able to use trigonometry again to find a missing measurement. We used that missing measurement to find the perimeter. So problem types 1 and 2 both involved using angle measures that we were given and trigonometry in order to find missing measures. Problem type 3, this time instead of being given an angle measure, we've got graph paper, and we're going to have to use the Pythagorean theorem. So that might look something like this. And in this example, finding the area is going to be easier than finding the perimeter, but it's going to require a little bit of counting because I haven't given us any measurements here. So we will count line segments along the base, find out that this base is 12 units long, and then we'll count a vertical line up the inside of the parallelogram for the height. The height is 4 units. So our area then is 12 times 4, which is 48 units squared, which we were able to find just by counting the base and the height. For the perimeter, we're going to have to use the Pythagorean theorem, which means that we're going to have to highlight a right triangle for ourselves on one side of the parallelogram. I've chosen to do it on the left here. You could do it on the right, it wouldn't make a difference. So in this right triangle, we can count the base and the height, see that the base of the right triangle is 3, the height is 4, and we will call that slant side C because it's the hypotenuse. And in the Pythagorean theorem, we know a squared plus b squared equals c squared. So in this case, that's 3 squared plus 4 squared equals c squared. 3 squared is 9 and 4 squared is 16. So we've got 9 plus 16 equals c squared. We add 9 plus 16 to get 25 equals c squared. We square root both sides to get 5 equals c. And then to find the perimeter, we're adding up all four sides. So we've got the 5 we just found, plus the 12 that we counted, plus another 5 on the right-hand side, plus another 12 on the top.